Hello, this is Getting Started with NodeWire. Today we are going to be looking at how to develop a node, that is a device that connects to the NodeWire cloud using the ESP8266. So let's check the Arduino. So remember that you have to download the Arduino NodeWire library as well as the ESP8266 board for Arduino before you can run the sample. So we quickly run through the code. There are two header files you have to include, which is the node and then the link. Several link files are provided depending on the nature of the connectivity you want to use. Because we're using a Wi-Fi chip in this case, so it's going to be a Wi-Fi link, so it's called ESP8266 link. So two objects are created, which is the node object from the node header file and the ESP8266 link, which is the link object. The node basically encapsulates the entire behavior of a node, which is the paradigm for handling a node. So then the setup function contains virtually all the functionality. So here basically we're setting up the link, the debug, and then the node. So first you create the serial port, which will be used for debugging, and then you set the debug output to be the serial device, and then the debug level is low level, so all debug messages will be displayed on the serial monitor, of course. So next we set up the link object. So link.begin reads the configuration that we already that was created on the dashboard, and then uses it to configure the link. So, but in this case, we're also providing some default values. So we're providing a value for the SSID and the password. Now, these two lines are actually optional because the configuration is already read from here. So, but because we're using a new chip that has not been configured yet, so we can actually provide these two lines so that we don't have to configure the chip before it can connect. So the next three lines is used to define the node. So in order to define the node, you have to provide a list of the input and output ports. So this particular one has only one port, which is called LED. I think I'll call it LED switch. Basically, it will be used to switch on the onboard LED on the nodemcu. Then you initialize the node, and then you use this opportunity to give it a default name, which is node 01. Again, this name can be changed from the dashboard later on. So next you specify the link that this node will use to connect, which is the link we just created here, LNK. So next you specify the callback functions that will handle messages coming to each of the ports. So you have a single port LED switch, so let's do that. So next, so this lambda function will be called whenever a message comes for this port. And then there are two parameters, which is the value that is being written to the switch, as well as the person or identity of the sender of the message. So what we do is we basically write the value directly to the pin. So the value comes as an end string, so it has to be converted using a cast before writing it to the pin. So, and finally we define the LED, the pin mode for the LED to be an output. And then the loop function basically runs the main loop of the node. So I think it is time to run the code. Because this is a new chip, the first thing that our code would do, as we are going to see on the serial monitor, is to create a default configuration file which is stored on the EEPROM of the nodemcu. The configuration file stores your device configuration, so it will know how to connect to the dashboard, what account to use, and what is the node name and the node ID. All these configurations, of course, can be modified from the dashboard. So there's a default account that comes with the already as default in the Arduino NodeWire libraries. It is test at microscale.net. So because of that, this node already has an account. So you can see that the configuration file has been created here, and then it becomes an access point for a minute. Then it discovered that we have a default access point defined, so it's connecting to that. That's connected. It's trying to register, failing to register. So we come here and we log in, test at microscale.net. The password, of course, is AB01 @. So logging in. So we're in, and we have a blank page. So I come node. So the first thing is to go to new node. So you can see that our device is already here waiting for us. So I click on it and press register. So once our node is registered, it disappears from there, and then we can now go to online nodes to see that our node is there. Yes, our node is there. Node 01 is the name of the node, and this is our port LED switch. The value is 0. So in order to interact with our node, we'll go to develop to create a layout. So a layout is basically a user interface file that is created in HTML in some kind of HTML. So I've created that. So open. So we come here and create a switch, which is a markup. Title equals to LED switch node equals node 01 and port equals LED switch. So at this, okay, so that is it. Okay. So I think we should be able to switch on and off now, right? Yes, so you can see that. So let's go ahead and be safe first. So we have to save our layout, accept the default name, and then we can deploy. Oops, I thought I saved you already. Okay, so I needed to wait for that. Successfully saved, and then we can deploy. So once you deploy, you can go back to the home page to see that your layout is there. Okay. No, it's not here. Yeah, it's here. Okay. So basically that's NodeWire, and I can press this. It's on. It's off. On. Off. For some reason the indicator is not working. I don't know why. Let me see. So the tiny indicator is supposed to actually, yeah, so it's working now. So it is on and this is off. So thank you. Tomorrow we'll be looking at how to use Arduino Mega with ESP8266 module to create a node for NodeWire. Thank you for listening.